And I guess we're live. Hello, everybody. This is another Comets live stream. Um, for today's live stream is we are going to try to continue on doing arrays. Um, Last time we know how to parse and like evaluate an array initializer, I guess. And today we are going to try and implement array, like parse and evaluate array access. And if we manage to finish that in less than an hour or so, we can like start designing objects. So before that, I want to like go through a couple of issues. So Anwar tried and found a couple of bugs. He filed issues for them. So one of the obvious bugs was this a equals 50, which is a declaration of a variable that never been defined, and we can assign to it 50 and it will pass. It won't add anything to scope, but it won't throw an error. This is a bug. I probably like didn't took this into consideration, and Anwar managed to actually create a pull request to fix this issue. So like he added me as a reviewer. I wanted to review it while starting working on the stream. So the fix for this is, as Anwar added, was like before evaluating the assigned expression, check the scope. If the variable name exists, it's cool. We can store it. We know that this is an override of the current value. If the value doesn't exist before, like it's not in scope, we know that this is an error and we can create an error and return it to the user. The test for this is like similar to unknown identifiers. We had another test and he added one where he just assigned to a value that is not there, and I assume this is working because the build is not failing. So I have nothing. I can like say thank you, and I will upload this. And I guess confirm merge. I don't know if I mentioned that it fixes. Yeah, I didn't mention it. Sure, we can close this, I guess. Yep. All right. That's done. Now I don't remember what's the current status of the repository. So yeah, we left it there. Yeah, so I pulled in the changes like that were pushed into master, and probably we'll need to create a new branch today for array access. All right. So let me remember what we did last time. Last time we did parse array expressions. So I'm gonna try to read the last tests that we added. Yes, this is the last thing that we had is like we had a variable that can contain an array, and we can initialize the array, and then we don't need to add anything. We just initialize it with a bunch of values and make sure that it actually works. Arrays can be nested. That's cool. Right. But the problem is we don't have any access. So what we would like to have is like a of what? So if we run the interpreter and we do var a equals 1, 2, 3, 2, we can see a, right? It being evaluated, but we can't. But what we want to do is like we want to do this. And the surprising thing is that this is actually spit out a value. Yeah, this is spit in some value for God knows why this is working. Um, yeah, we'll try to figure why this is actually working. Oh, this is super weird. Um, let's find out why is this working. Um, can we go? All right, let's go to the REPL. Hmm. I'll add a breakpoint here. I want to see what syntax tree is getting generated. So A equals something like this, right? You can skip it, I guess. I want to note this. All right, so let's see the root node. So root node has a parser statement, has an identifier expression, and an array literal. Well, that's super weird. Oh, so it parsed it in a very weird way. It parsed it as like one identifier beside one array literal. I don't think we wanted to do this, but like today's effort is gonna be about fixing this. Um, since we don't have anything that kind of parses or says that this bracket opening bracket operator should be handled differently, there is nothing to say like how can this work. So I guess we can go to the parser and try to make sure that our array tests are correctly updated. Let me go to the right. Um, our array tests are the last one that got added, and we want to be able to add a test for this. So I'm not sure. What should we expect? So if I have something like this, I would like to have an identifier, identifier expression with um, um, identifier expression. How did I? All right, so it needs a name. So the name is A, and here we can see it like in two ways. We can either see this as like we can parse it differently or not, or like we can consider this a special case and we handle it differently in the parser, or just consider this as another kind of binary operator and we like consider we treat it such as this, like we have an as in any other binary expression, we have an identifier, then we have an operator. In this case, it's this operator, and then we have a expression, and we have something, and we have a closing bracket. And having this will enable us to use the already existing machinery to kind of parse array accesses. I didn't just think of this. I thought about it like when starting to implement arrays, and I thought it would make a good idea about implementing this in a very simple fashion. So I think I'll go with this approach, and if it doesn't work, maybe we'll make some tweaks. If chat have any suggestion, feel free to kind of send in your suggestions via chat. All right. In the meantime, this is what I'm thinking. I'm thinking to have a binary expression. I'm not sure how to test binary expression. What do they expect to have? An operator. Cool. So I'll just copy this. and right, and the literal would be open bracket, because in theory this is the operator, and we need a number literal, which is 0, and that's it. This is what the parse tree should look like. For people in chat, did you get the approach? Do you have any suggestion about the approach? So yeah, we can go into something buzzing. I don't know what it is. Right, we can go to the parser now and try to make this work. So the existing machinery about this was straightforward. So we had a bunch of functions that we tell the function, whenever you see a given operator, do this. In our case, whenever we see an open bracket and a prefix function, do this. Whenever we see an operator, like it's gonna try and interpret it as an array literal, the thing that happened before. Zakaria, hello. Utman, hello. If you guys have any suggestion about the approach of parsing arrays, please feel free to comment on this. That'd be nice to actually get help from outside. So now I'll try to register a binary function. Let's call it parse array access. Zachariah said, if possible, can you please, or someone from chat, explain to me the project briefly? Is it the first time? Is this the first time actually watching the live stream? If it is, I can like re-explain. That's no problem. Well, I'll explain anyways. So what we're building here is like for educational purposes, we are trying to build a simple programming language that is interpreted and not compiled, and we want and I want it to be like to contain a lot of features like from different kind of flavors from languages. We don't have a type system, but we want to have nice syntactic sugars. We wanted to try and build the project in such a way that it has it's simple, educational, but it's also like somewhat complete. Like in future episodes, once we're done with the interpreter, we want to add like standard libraries, build system, and like some kind of packaging system. Second job, but wasn't pay much attention. Believe me, I do that in my own streams either. No worries. If you still have questions about the project, yeah, Ajman. I'm building an interpreted language in Go. Yes. All right. So let's call the function parse array access, and this will get called whenever we find an open bracket. All right, let's create the function. This is the left part of the expression. So the access is written in a very bad way. Parse array access. Yeah, cool. Now we know that this is an array access. So what we need to do is like to create the array access expression. And since we don't have this yet, I'm gonna return null and like go and try and create it. So I suppose we have something standard parser. Yes, this is node. What we want is like a new syntax node, which is struct type index access. Access with two S's. is a struct. The index access will have an expression and probably an identifier. Unclear. Yeah, it should have the identifier, this for sure. Right. It should have the identifier name, and it should have yeah, it should have the identifier expression. Identifier, which is the left expression, and the I'm making it an identifier because it could be anything actually. It could be something that when evaluated, it yields an array. It's not always going to be a named variable. That's why I'm making it an expression. And the left part could be an expression as well, which is like the index. And for sure, we don't know, like the index could be anything for all we know. And the index access can have an operator, but since an index access have only one thing. Zachary is saying, I'm still a student. I've got no experience with Go. I'm gonna rewatch the other episode and pay attention with you, right, to get to know how proper we write code. Yeah, so Go is pretty simple. It's like it's a simpler version of C, I guess, if you can think about it. Like it has a lot of things in common with C, but it's quite simpler. You can learn it like in a couple of days. You can pick it up. Yeah, thanks, Zakaria. That's very nice. Um, as I said, like Go, you can pick it up fairly quickly. I don't think you would have much trouble like picking up Go. The interesting part, I guess, about this project, or at least what I think is the writing a language from scratch with all its intricacies and dependencies, because it's educational as to other people as much as me. I'm also trying to learn a lot of stuff, but I'm forcing myself to do it, so I do it on stream. Otherwise, I won't be doing it because sometimes it just gets too hard. So getting back to this, so we want the index access to be an expression. Right. All right. So the literal value, I don't really use it. The visitor should accept as a visit array access with I. And statement, expression, and literal. I'll leave them empty for now. I'll create this function. Now, this is gonna break some things. Like I'm gonna make sure that this is added to the correct place. So we want this to be here. Right. Let's go to the parser test, and this file has gotten huge. I would like to break it up, but node visitor. Right. So we need to implement the access, and to implement the access, we need I want to make sure that the current node is t.expected, t.pointer, t.pointer plus plus, and I don't think we need to assert anything. We want to make sure that the actual current node is, yeah. Hmm. Should I just create a binary expression? Anyhow, that's not an issue right now. So let's make sure that the access dot identifier dot accept the current visitor is t, and we'll do the same for the expression index, right? And we want to make sure that the current node dot array access. I don't remember what we called it. Array, no idea, totally forgot. It's index access. Huh. Yeah, because it I guess it's a better naming. So current index access. I'm not gonna use it. I'm just gonna say, hey, index access and is her index access. If not, is index access. Or at least I'm gonna do a search to t is index access. Right. I have another implementation of this. I guess it's here. This is a debugging implementation. Index. Oh. Node visitor. Right. So how do I do this? So print indent. Heat up buffer. The right string. Index access. And then p dot visit expression, which is the access dot index, and before is the identifier. Right. Now I guess it still builds. Only now the test failed. But that's okay, I guess. So can we make this run? It'll break. It should be true, and it's not. Yeah, so what we want is like an array access, an index access. On the left, I want an identifier expression, and on the right, I want a number literal. Yeah, I guess the test looks more correct now. And of course, this is gonna blow up because we don't have anything for this. All right, so let's go back to the parser. So let's create the index access now. And for the index, for the identifier, it's left index. Right, and we want the parser. So we are at the operator. So we want to, I guess we want to advance because we're sure that the next one is gonna be like an open bracket, and p dot parse expression. This should be the index access dot index and p dot advance and expect next. I'm not sure. The next token, right? So advance and expect. But the next token is elixir dot close bracket. Is this correct? I'll see. And then we return the index access. So let's go back to the test for a while and see if this actually yields anything. Right. So let me debug this test. Although it contains 1, 2, 3, 4 tests. I'll have to skip 4 times. 1, 2. I have a lot of breakpoints that I should remove probably. So in test, the expression is this. Now the expression is access. The root node is one statement with an identifier expression, and then an array literal. So it's still not picking it up. Huh. Well, this is wrong. Or maybe maybe we need a better priority. So for the precedence, yes, I guess we return minimum. Yeah, so I guess there is an index, and it needs to be better. We need it to be 4, and then if we have elixir dot open bracket, we want it to have index. Now, if we rerun the test, oh, what happened? Just failing, not doing. Oh, I removed the breakpoint. Sure. First, second, third. Yep, fourth. Now the root node is a statement that has one index access, and the identifier is an identifier expression, and the right value is a number literal, and this is what we wanted. Now if we let the test continue, it will probably fail somewhere, because the parser is saying it has errors, right? So maybe because this is just because we're stopping somewhere that we shouldn't be, or we're not stopping where we should be. All right, this is a little bit boring. Yeah. So the parser's error. Let's see what the errors variable has. All right, it has one message that says expected close in bracket, and it got an end of file. Okay, so we shouldn't have done that. So go into the parser again. So advanced and expected the current token to have something. And all right, I'm not sure what actually happens here. So what's the current test? Yes. So left is parsed correctly, which is an identifier expression. And we are at what's the current token? The current token is a number. Yeah, so parsing the expression actually, yeah, so we need to make sure that the next expression, so it's not advanced and expect, so I expect next maybe. Expect next would do the trick. Yeah, now the test passes. Great. So let's make a little bit more, another test that actually has something. So we want to make sure that this doesn't alter wherever's in front of it. If we have a 1, I want to have another number, literal, which is 1. If I run this now, it still works. So it's still able to parse numbers after it. Great. How about doing this now? So let's do an array access, but this time let's do it with a string. String literal, and the value is string maybe. Yeah, it still works. Now let's change this into a function call. So A, but here I'll do a function call, B. So I'll have an identifier, but here I'll have a function, a call expression. Yeah. And the name of the function is B. Right. So for all of these, it still works. Fine. So what if we invoke the brackets on something other than an identifier? So let's say we have a B, we have an A that actually returns this. So we have a function that return this. So we have probably an index access that has a call expression that has a name A as the name, and right. Okay, so it still works either way. Great. Are there any questions in chat about this? Okay. So parsing is all right. I guess we can see how can we evaluate this. I don't remember last time, did we create a built-in array? Um, maybe we did. Maybe we didn't. Unclear. Yes, we did. Cool. All right, so let's use this to make sure of some things. Let's go to the evaluator and go to our huge eval function and make sure that when the parser is an index access, I want to make sure that the left value, like I'm gonna do return iv ev, that evaluate eval. Did I call eval or evaluate? Eval. Array access. Eval. We are going to create it. So left, we're gonna call, so we know that the index or the left portion of the index access expression should return an array no matter what. An array or something else that can be accessed with a bracket. And for now, since we only have arrays, we want to make sure that actually array is the result of an eval. So if we do eval array.index, so this should not index actually is the identifier. So we're not sure about anything here. So we want to make we want to evaluate and make sure that this is actually an array. So if array dot type is different than array, so if this is not the case, I want to create an error. Return create cd create error. Expected array got we don't know what's this, array dot type. Cool. Now if it is an array, we can evaluate the left part. So eval the array.index. And the index for now, since we only have arrays, we want to make sure that it's actually an integer. So if the array, if the index dot type is different than a standard int type, return cd.create error. Expected int, comment int, and here comment array. Got, we don't know, in dot type, index dot type. Right, now if we both of them are actually of the correct type, we can do we can return array dot if index is smaller than 0, or index dot value, of course. I guess we should index val equals index comment int, and array val is array. We can make this cast without actually doing any testing, because we know for sure that the index in the array passes the sanity check of being arrays and integers. So index value dot value, if this value is smaller than 0, or index value dot value is bigger than or equal than the array value dot length, return std.creator array access out of bounds. Array of length d value was index was %b, and so the value is index tab. The length is the array value, not length, and the index is index value dot value. Cool. What is he yelling? Oh, that's weird. Let me upcast it for now. Otherwise, we know that we can do this array value that values that int of index value value, right? I guess this should cover array access. So let's do a very quick pass. So at first, we make sure that the left operand, which is the array or the expression that evaluates to give you an array, is actually of array type. And if not, we report it. If the value of the index position is not an int, we return an error. Note here that we can have like other structures such as maps or sets or whatever that can have key accesses, and any update or addition to these kind of structures should entail having this implemented. But index value is the same, and we do the quick index bound check, and then we do it. Cool. Ultimate, I'm sorry to interrupt, but why do you need casting when you already know the type of array val and index val? Does Eve that val return a specific type other than the actual? Good question. No, it doesn't. The short answer is like the evaluator's eval function returns a commit object. I always need to check for the type when returning from an eval, because eval can return anything, right? Because we can give it a function that will return a commit object or a commit int or another type of object. And since we are in Go, and there is no inheritance, no hierarchical structure, so to say, we are bound to do it like this. I hope this answers your question. All right, so let's make tests for this, shall we? Remember adding array tests. Cool. I will copy them and create array access tests because we implemented them in 2 different episodes. Okay, evaluate array declaration. We'll call it evaluate array access. And let's see. So let me remove a bunch of things. Yes, I'll remove until here. All right, cool. So now we have an array that has 2 elements. And if we do so did we have tests that actually do this? So what I want is not check stuff in scope. I want to assign them to things. All right, I guess I'll assign them to random things in scope, and maybe we'll find something better to do. So B is A of 0. Now we have an array access. I tested this before, so I'm not gonna test it again, but what I will test is like, I want to find B in scope. It's man, it does, thanks. Yeah, sure, no worries. And type. So I want to make sure that b is an integer because the axis in A was an integer. And I want to make sure that b is an int, b value. Int type and b value, that value. And this should be an int 64.0. Right. So if what I wrote worked, yeah, it works. Cool. I love it when I write something and it works from the first time, although it makes me a little bit suspicious. So let's write a couple more tests to make sure that this is actually working. Now I'll do, should I? Yeah, let me change the type first. Let's say 12. And then I want to make sure that B exists now, but it's a comet stir. And the value now is actually a 12. All right. So now it doesn't work. Well, because this is not a comet stir. Stir side. All right. It still works. So let's do something a little bit complex. I'm not sure if we do this. So let's do a function. Let's have a func get array, right? And this should return static array. Return 1, 2, 3. And B should be get array of 0, right? I want to make sure that this is actually its scope. And the value is 1. Oh, that's incorrect. The value now is 1. And it doesn't work. Let's see. Index our array is 0 at length 0. That's unfortunate. I wanted it to work. So I'm not sure where it broke. So let's see the top of the stack. So call side that variables, that variable name, eval arguments. Why are we doing this? So we evaluated the call expression. And so created a new scope. And we bounded something to it. So why is it failing here? Although the error, I know it's coming from somewhere in here. So let me make sure that it actually works. So test 1, test 2, this is test 3. So the array is an identifier, which is a call expression. Like when this is evaluated, yeah. Evaluating this call expression we have problems in evaluating call expressions. So if I'm not mistaken, like doing this should cause problems. So like func d return 1, 2, 3 or 1, 2, and then we call in d d of 0. It works. Oh, now this is weird. Why do we have problems in there? So evaluating the call expression. I'll add a breakpoint in here and make sure that it actually does what I think it does. So the call expression here has a name. If it's a built-in function, it's not. Now we found the callable and it's a function. Now we had the function object. We created the call site scope, which is a new scope from the original scope. And then from all the parameters that it has, which it doesn't have any, as far as I know, function object parameters has 1. Why does it have 1? Oh, it has 1, actually. It was never supplied, that's why. Oh, silly me. Silly me. Yeah, the test works. Yeah, that was stupid. Ah, I hate it when I do this. All right. So array access works when the function is returned. Now we do the I guess this is the extreme case. It's like to have nested accesses. So let's do 1, 2, 3 of 1. And this time let's make the value be 2. And the value should be 3. All right, this works. Okay. So how about having a huge nested array? So var a equals 1, 2, 2, 3. And I nest this. So I make a of 0 of 1. So this should be 2, right? Let's make it a little bit distinguishable. I'll make it 42. So this still works. So we have arrays that are working now. Cool. So now we, I guess arrays are completed. So the nice thing that we want to have is like to be able to call methods or have specific functions on arrays, because arrays on themselves, like static arrays, are not that nice. So we would like to have like an empty array and then add stuff to it and remove stuff from it and sort it and do operations on it. Otherwise, like, we can't do much. But before we do this, we need to be able to have like a notion of an object or a struct to actually make the array a struct and be able to call methods on receivers being structs or objects. I'm not sure what to call them yet in Comet. Not having a design spec for the language is kind of weird. All right, so let's commit this. We are almost an hour in stream. Maybe I may add may start a little bit more. May continue a little bit more. So add array access operations. Commit. 2 files contain problems. Sure. So the printer has some problems and the parser has problems. Unused parameter statement. Sure. Here. Sure as well. Variable x collides with important. And so let me rename it x. Commit. Nice. All right. I don't know if Anybody still watching? Anyhow, it doesn't matter too much. All right. Let's. So this is a branch I need to push on its own. So probably. Find push origin last time. Origin master. Everything is up to date, really? Now push feature array access. Really, dude. Cool. All right, now we have this branch. I'll merge it in later. The most important thing is so let's merge the PR, create a pull request. Let's wait for the checks to finish. Hopefully it finishes fast. Oh, sure, let's take its time. All right. Cool. All right, merge the pull request. Cool. Okay. Now let's check out a new branch with, let's call it feature objects. Now, how would we like to design objects? That's it's a new thing for me. So let me pull up the old README. So the README contained, slideshow viewer portion. So the view contained, the document here contained like a way to declare objects. So the first draft of the language contained the ability to have to treat functions as expressions. Since we removed this model doesn't work anymore because functions are named and they should be bound to a given scope. Now, declaring objects like this, I would assume. So this is like similar to the way that JavaScript adds fields and methods to objects. But I don't think we'd want to do this. For the people who are watching, what do you think? I'm not sure. Like, I'm inclined to not do the JavaScript approach. I wanted something since Comet is a dynamic language, something such as Python would be nice. Yeah. but no magic method maybe. Yeah. So if we end up like going like the Python way, this should be changed because the grammar of the language is different now. Right. Sure. Let's do it as Python way. So what we will end up with eventually is, so that we have, this is not the case anymore. So we have function add, which will return a and b, and is bigger is a func itself. Declarations should be like, an object would be something like this. I imagine something like struct data. And the schema would contain would have some form of init method like init. I'm gonna break a and b and c. Func. And it would have some this dot a equals a, etc. This dot c equals a plus b. Maybe do this. Func do stuff. I don't know. Do something. Return a plus c. Like, what I'm thinking about is like, this needs to, if we end up going this way, we would probably need to rethink the whole scoping thing, because here we have kind of an implicit scope variable. So this is always existing within a method, defined on an object or a struct. And here we are returning a plus c, and this should mean this dot a and this dot c. This is a syntactic sugar of doing this, but is this a good thing to actually do? And init is some form of specific method to do initialization. Yeah, it's man. I don't. There is a little bit of lag. So the thing is, I wanted to, like, you can write this dot b and like, you can write this. This is totally legit. So to do this is dot c. But I don't want to add to the user like the burden of writing this every time. So a lot of languages like allow you to do this. And if they are not in scope, like if I don't have var a equals something here, the interpreter would assume that you mean this a and c as well. So in this case, it will consider this a, and the we'll consider it something like this. But this will imply having to change the actual scoping, which I'm fine with actually. I'm not too proud about the implementation of scoping. It's not the most performant implementation, but performance was never part of the equation for comment. All right, we do what's convenient. Oh, syntactic sugar. Yeah, I know, I know. There's a little bit of a delay. Don't worry about it. Mm, okay, so to not like think about it too much. Um, I'll try to like we need to think how to parse this. So we need to introduce a new lexicographical new lexeme, which is the struct keyword, and we'd want to parse this as a struct data with a block statement. So this is the way I see it. So this is a struct and identifier and a block. And the block struct declaration. And the block would be an open bracket, functions, and I don't think you can add anything. Yeah, for now, because if you want to have fields, you should declare them in an init method, which is a function as well. We just treat it a little bit different whenever we create. All right. So how to create this data? So data is created something like this. We do data. Um, do it like this. ABC will give us a data variable. What if we have a function that is called data? Should we add a new keyword? I'm not sure. I should prepare a little bit for live streams before. Otherwise, people are just watching me struggle to come up with something. So adding the new would be like a little bit too cumbersome. It's gonna be fine for most cases. Like most languages have new. It would have been nicer to be able to say data without the new keyword. But I don't think we can do without, because like otherwise it would be I would need some sort of rule spec that says, hey, if we have a data identified struct and a function that is named data and a variable that is named data, so we are going to pick this one and consider the one that's making the call. And this is a little bit like too complex to be educational. All right, so let's add the new keyword as well. And for accesses, we'll have like something like data that do something. And this is the new spec for languages. It's necessary top of I don't know. I would call it that's me struggling. But yeah, thank you. All right. So let's start with trying to implement this. I'm sure I won't be able to finish this during the stream. I'm a little bit tired, but hopefully we'll be able to continue it during the next stream. It won't take more than 2 streams to actually introduce objects. Right. So having this said, so let's introduce the new 2 keywords, which are new and struct. Right. So let's go back to the Lexer. I have keywords, right? I don't think it's gonna take too long to actually add them. Keywords are easy. We have new already. That's nice. I have struct. All right. Nice. I guess this should add them. All I need to do is like add a couple of tests. New. What did I do? Do I have, yes, this is the test. New struct. All right, and then this should still work. All right, cool. So now that we have this, how can we make this? So we need to parse it somehow. And a struct declaration should have a bunch of function declarations, right? To keep track of them. Okay. So let's go back to the parser. At least I'll start in with the node. Oh, sorry for that. So let's add another type, which is struct declaration, which is a struct as well. All right, so every type should have a name, which is a string, and it should have a bunch of function declarations, so methods, which is an array of function statements. I guess this is it for structs for now. I don't think I'll add anything else for now. So let's try and make this. So the struct declaration should be a node. And the visitor should do visitor.visit struct declaration. Let's add a statement. Which statement it is? A struct declaration statement. Well, it is a statement, but let's call it visit struct declaration. And let's make this a struct declaration statement. Could be better. Cool. Now with the addition of every little thing, the visitor should be updated. So indent, and we print the name struct with the name, which is statement.name, and statement.methods, that's for p.visit method is func statement method. Yeah, that's it for this one. For the test, I guess it's gonna be more trickier, so I'll leave the implementation empty for now. I'll let it panic. And let's go back to parser test, or at least to the parser. So the parser, we know that whenever he finds one of these, he's gonna like treat it as a statement, and I'll add another entry here for struct, and saying return p.parse struct. All right, how do we parse the struct? We know that the current statement is, the current node is a struct. Okay, so we create the p dot doesn't look right. So we create struct state and p.advance dot name equals p dot current token dot literal, because skip the struct keyword, and p dot advance skip the literal, and then we'll make func statement funcs. Let's give it a size, and then I'll advance skip the opening parenthesis, advance and expect that the current value is a open parent, and then while like I'm gonna do something until we reach end of bracket, and not parentheses but open brace. And while it's not, if p dot current token dot type is close and brace break, otherwise functions equal append functions and p dots parse function statement. Should probably be like this, although now it returns a statement. All right, p parse function statement func statement. Yeah, so the variables won't be declared. If you're familiar with Python, it's kind of similar. So you don't have top level variable or fields, but you initialize the fields as you go, either at construction or something like, or similar. So if you invoke the constructor, you get a this pointer and you can call whatever this something equals this, and this will be a declaration of the given variable. So if we parse the function statement, and we need, I'm not too inspired about name right now, so if I can cast it, we need to cast this somehow. So func statement dot func statement. Okay. If not okay. What happens? So we return creates error. No, I don't think that's the case. So what how do we create errors? Yeah, we report. So the current token expected a function declaration, and we'll return whatever. We'll return a struct deck. We'll return our struct declaration so we don't break. So this should implement statement. So we don't break the actual parsing. Otherwise, we just add this in here. Not functions, but do struct deck dot methods equals functions, and return struct deck. Yep, I guess they are of the wrong type. All right. So we skip the literal, skip the opening, not parentheses, but brace. And until we find the close brace, then we stop. All right. So let's, yeah, well, this file needs to be split somehow. Um, struct. And nothing else. So we need to make sure that the so the current is um, we'll do as we did here. Current node dot. I'll try to cast it to a struct declaration state and say that struct. If not, I'll search foo is struct, and we make sure that the if we cast it, we want to make sure that the current node actually has the same value. The struct value t.t struct value dot name and statement dot name, and then for each of those, so statement dot methods dot for t dot m dot accept not m but t. Okay, so let's see if this worked at all. But before that, I want to make sure that I want to see the syntax tree that get generated. All right. So the struct declaration, we created it. We move. Now the name is data. Good. Good. We break. We make the functions and we return. Assuming this works, I guess this should, yeah, so the test passes. Let's make another one. That has one single init method in it. Func init ab, no parameters, no nothing. Right. So this should have a declaration statement. We have a function statement. Name is init and nothing else. If I debug this again, second time, let's see. So the function is created with the correct name. It's not okay, it's created. We break methods. And if we continue, yeah, it panicked. It panicked here. Invisit block statement. Oh, yes. Yes. Every function declaration should have at least a block statement. Even an empty one. So now it didn't panic, but it should be false somehow. So we have errors. Cool. Let's see what the errors are. So next. All right. So does the parser have errors now? I don't think so. So if it's a closing brace, no. All right. So after this, errors, we have no errors. Current close, yes. So do we have errors here? No. And then we have a function. All right. It has no parameters, it has a block. And then when we return, we parse declaration, parsing statement, it's not, we advance. It's not in the file. It's in the file, but we added probably errors in here. Yeah, that was my suspicion. Because we expected something. No parsing function found for this. So we need to make sure that we advance in here. p.advance and expect lexer.close brace. And running this now should work. Yeah, it works perfectly. Right. So to make sure that the parsing actually works correctly, let's add another test, but this time we will declare stuff after it. I'll declare another function here called to, which won't do anything. And I want to make sure that there is a 2 and there is an empty block statement. So this works, which means that we can still declare stuff after it. And this kind of concludes that we actually can parse structs now, but making them work is another story that I will actually leave for another stream. I'm feeling a little bit tired. So unless you guys have any questions, I'll stop here and I'll continue like in the next stream. Let me commit this. Sure, thank you guys for watching. Good night. Methods. Okay. Can I commit now? Can I build? Make sure that it actually works. Go. Alright, everything still passes. Cool. Alright, guys. See you later. Bye bye.